One way or another, we are finding out how hard this needs to be hit to fully break.
Some weeks are about big ideas. Others are about laying the groundwork. But this one's a bit of both. In this episode, we're investigating theories, making some serious kit for the build, and we try to figure out what on earth's going on with Moose's very heavy clutch.
Are you okay, buddy? What's his vigour?
We want to start testing our idea for how we're going to construct the habitat shell.
Yeah, if you saw our most recent Patreon video, we did kind of explain our ideas behind it, but we've actually pivoted from that again already in a couple of days since then. So what we've landed on is essentially making the habitat out of insulated foam boards, reinforcing it with GRP sections and structural pieces, and then fiberglassing the whole thing.
Like a boat?
Similar to how they make boats and stuff, yeah. That's a very brief overview, and we'll kind of explain what we're thinking as we're doing it. But for now, what we're going to do is we've cut out a bunch of bits of foam. This is 50mm thick insulation, and we're going to start by making kind of the side profile shape that we want the habitat to look
Peach chamfer, we'll call it.
I really like the look of like heavily chamfered, like overlander style boxes, even though our truck's not going to be overland at all. So if you imagine this bottom piece is the floor, then we have our chamfered piece, and then there's the wall. So what we're going to do today is test two different resins, epoxy and vinyl ester resin. And we've got a few different thicknesses or weights of fiberglass mesh.
I think this is the first of many tests.
Yeah, probably.
Okay.
It's going to be fun. We're finally almost working on the habitat. Okay, we've got all of our different bits of fiberglass cut up. Do you want to talk people through it?
So for each of the two resins, we've got a few different variations, because some of these, especially like the 600-gram weight and the plain weave, they could be a bit harder to conform into the inside corners. So we're going to try a version on the inside and a version on the outside, and hopefully that will help us figure out what on earth to do.
The weight is measured in grams per square metre, so the higher that number, usually the thicker it is and the more dense it is. So we've got 600, 440 grams, and then this is 220 gram twill, and this is the 280 gram plain weave.
The twill and the plain weave, these are like the finishing layers. They go on last because you want to use a much finer fiberglass towards the end to reduce the need for sanding and to give you a nice surface. But then we're also going to be using peel ply. So
apparently if you use peel ply, it's basically like a layer that doesn't stick to the resin, and you peel it off afterwards, and it leaves a really good surface ready for more fiberglassing or ready for painting.
How are we going to do this when they're massive, like 6 meters long?
I think you can glue it in place, but you could also like pin it in place. Okay. How's it look?
Yeah, I think that's it.
Yeah?
Pete's chamfer.
Yeah, so this would be the floor, this would be the wall, that would go off 2 odd meters, that would go up 2 odd meters, and then this is our cool chamfer.
It's an extrusion.
Yeah. Okay.
I need to make all of them, all 4, because once we've mixed up the resin, we got to just get to work. So.
Okay, do a transition. Okay, here we go. We're starting off with the epoxy. While Hayley does that, this is the first one we're going to start with. We're doing the outer layer, which is why it's that way up. So that would be the outside of the truck, imagine. I'm going to do 2 layers of 440 biaxial with 1 layer of twill on the top. Oh yeah.
I'm just going to slip it on. You've watched more videos than I have of people doing this. How thick do they start?
The videos I watched were all people putting fiberglass onto plywood. So they put a layer down that absorbs into the plywood.
How absorbent is this insulation?
I don't think it's absorbent at all.
Okay.
So you've got to be quite careful with what foam you choose, because if you use polystyrene or XPS or that pink insulation foam you can get at B&Q and stuff, that will just be eaten away by the resin. So you have to make sure you pick a foam that is suitable, because it will literally just dissolve away. And so we've gone for polyurethane because it works well with epoxy and polyester based resins, and because it's quite strong, so it's quite easy to get into shapes and like cut and stuff with, especially woodworking tools will do it. How did that go?
Yeah, well, it was easy, but whether or not I was doing it right.
Layer 2. Well, it looks like you know what you're doing. It looks really good.
Really?
Yeah.
How can you tell?
Well, it doesn't look like it's not fiberglass.
Okay, so the last layer on this is going to be the twill.
Got these metal paddle rollers, which you like roll on to get rid of air bubbles and stuff at the end, but to be honest, it doesn't look like
I could give it a light rolling.
So it can get rid of excess, but I don't think there is any.
No, so I can see pushing that it has made some resin come out.
Okay, well that's good.
Yeah.
Okay. First fiberglass in.
I gotta put the peel ply.
Oh yeah, okay. That looks so professional.
Really?
Yeah, it looks really good. Doesn't look any different to the other ones I saw on YouTube. I like how we're basing this entirely on things we saw on YouTube. Is it my turn now?
Yeah.
So this foam came with like a aluminium, like shiny card wrapper all over it, you know? So we peeled it off because you want to adhere the fiberglass to the foam, not the backing that's on the foam.
Yeah, it peeled off very easily.
Yeah,
so
that would have been the weakest link in the whole thing. Okay, right, what's first?
We're going for 600 grams.
Is it this one?
Yeah.
Oh yeah, that's thick. So this one, the bottom layer was 600 grams, and this one I'm putting on now is 440. Still biaxial, so it should be strong. Okay, we've got to move a bit quick now, because it feels like the epoxy is starting to go off. This is the final layer. This is just a plain weave. So it's much cheaper than twill, so if it gives the same nice finish, then we can just use this. Yeah, we're just trying to see which is going to be the best way to go, because, you know, it gets very expensive very quickly, all this stuff. The main test is between the epoxy and the other resin. Okay. Peel ply. Cool, okay, so we need to get the other resin bits done now, and maybe we'll do it at the same time, just for speed.
Compared to the epoxy, this final ester is much thinner and less sticky. I can't really see how much I'm applying because it's getting absorbed so quickly, and it also stinks. I have to tighten my mask up. But that's all the exterior is fiberglassed. We just need to wait for that to cure before we can do the other side. So we'll pick this up again later.
We're here at FH Brundle, who have kindly sponsored this episode. We're going to get some aluminium and some steel for our upcoming projects, and hopefully get a sneaky behind the scenes tour of what goes on as well.
Brundles have been supplying metal to the trade for over 130 years, and they stock a huge range of products and materials suitable for smaller home projects and mega industrial fabrications. They stock everything from box section, angle and bar to steel and aluminium sheet, GRP, gates, railings and more. Many of their products can be cut to order, so you don't have to buy full lengths if you don't need them. You just tell them what size you want and it turns up ready to go. They have branches all over the country, so you can order online, over the phone or in person at your local trade counter. It's super easy. Once you've ordered, follow the lines to the collection point, ring the bell and load up. Or get it delivered. Ours turned up on a lorry the next day and it only cost a tenner. If you want to give them a try, they've given us a promo code that gets you 10% off when you spend £150 or more. Check out the link in the description. And thanks again to FH Brundle for sponsoring this video. You might be wondering why you're watching us pull up and replace our workshop floor. Well, the steel that we just had delivered from Brundles is currently being laser cut into parts for a piece of equipment that's going right here. But the floor is only 9mm OSB and it definitely won't be able to take the weight. I'm so happy that we get to reuse the aluminium tread plate that came out of the horse box too. Looks very nice.
That's a nice threaded rod.
Pretty prepared.
Explain what's going on here.
Well, I don't really know. We're building a welding fixture table.
Hayley's always wanted a welding fixture table, you see.
So we bought some plans and they're basically just laser cut parts that all slot together.
It's really cool. You've got these plates that bolt down and then pull these like stiffening plates and the tabletop together, because otherwise it kind of bows, because it's only 6mm plate.
And then we have some sides that go on as well. These guys.
I'm quite glad we got the 6mm stuff, because making this out of 8 or 10mm would have been so much harder.
Oh, we would not have been able to lift it.
I don't know how we're going to get this in the workshop as it is, but you can kind of see why it needs clamping so much, because look how bent it is. It gets so warped.
The laser's very hot.
Every clamp we own is on there. So now we're kind of going to weld everything that is good and tight and then move the clamps along and weld as we go.
Yeah, because we didn't have quite enough to go all the way to the end.
And I don't want to buy any more.
No! What's that for?
I did transition. I just did a YouTube transition.
Don't know if it works like that.
Okay, so I don't want it to all warp and move while I'm welding. So I'm just going to tack these 5 squares up and then lay down like 1-inch fillet welds. And then, yeah, we'll move the clamps and I'll weld and move until the whole thing's done. And then that way, hopefully everything should remain good and flat and strong. The welding is done. Feels very sturdy. These are some nice welds here. Who did those ones? Should we show them your welds? This was your first.
No.
This was your first one.
Oh.
That was the first. To be fair, not a bad first weld. But then by the end, it looked like that.
That might be one of yours.
No, that's your one. And like that, look, you've got some little dimes going on that one.
Yeah.
What do you think about MIG welding then?
It's a lot easier than TIG, isn't it?
Yeah, it really is. You're a
But-
natural.
Thank you. I think that practice with the TIG did help.
So what we do next?
Legs. These are arms.
There you go. So these are the corner plates that hold the legs. There's a few different mounting options and stuff, and they slotted in perfectly first time.
Yeah, no
They're
persuasion needed.
I mean, this kit is really cool. I'm very impressed with it.
Oh, look at that
yeah,
one.
Nice. I went for the 900 by 1.5 meters or 3 by 5 foot because I think if we made anything bigger, we wouldn't have been able to move it. And getting everything laser cut is quite expensive.
Yeah, they
because-
seem to charge by hole.
Yeah, they charge by how long the laser's on for and running. On the 8 by 4 foot one, there was something like 1,200 holes to cut.
Yeah.
So it was a lot of run time. This was much more attainable. And to be fair, I don't need anything bigger than this. I just wanted an 8 by 4 foot welding table. I'll leave a link to the plans. The guy who made them is a YouTuber, and he has got a really good video on how to put it all together and all the accessories and stuff, because there's loads of other things that come with it. Get it, get it, get it. So, now that you have all some MIG welding skills, do you want to weld these on and I'll go cut the legs?
How? Where? Where do I do it?
You gotta weld these tabs.
Just
Put a little bead in there.
along all them?
Yeah.
Boop, boop, boop.
You can handle that, right?
Okay.
You're a pro now.
No. Whoa. Bulbous.
Okay, done. How'd it go?
I think it was okay. It's a bit windy today. The very last one got the wind.
Oh, did it go all crunchy?
But it works.
Good job.
Day 2 of fibreglass testing, and we remembered to bring the scales this time. We measured by volume before, which might not be accurate enough. Both of these resins have their mixing instructions by weight, so we should probably follow them. These inside corners are a little bit of a pain. The epoxy is so sticky that it keeps pulling the glass back out of the crease, so actually the vinyl ester wins here. The heavier fiberglass is also easier to work with, which is surprising. It just kind of stays where you put it. There, the test pieces are finished, and now we wait.
Hello and welcome to the gearbox. This is the clutch slave cylinder, I believe. And basically what it does is when you step on the clutch pedal, it pushes this pin out
With hydraulics.
with hydraulic oil, yeah. And that actuates the clutch. So you can, you know what a clutch does. I don't need to
So you
explain
can
that.
change gear.
Yeah, all the clutch related things. The clutch is super, super heavy. Like, they are notoriously heavy on these old trucks, but it's really bad, super uncomfortable. Like, I have to fully stand on it. We have an idea. What we want to do is replace this hydraulic one with an air-assisted clutch booster. And basically what that does is it still takes the same hydraulic feed in from your clutch pedal, but instead of it driving the pin forwards, it opens a valve which lets air in, and then the powerful air compressor system on the truck actuates the clutch. So yeah, that's the plan. I can't find one that's made for the truck, so it'll be one that's very similar. So we'll just have to figure out how to retrofit it to our gearbox, which shouldn't be too bad. But whilst taking this out, these crusty old bolts, one snapped in the housing of the gearbox.
That's the first bolt that we've snapped.
It is! So it's in there, and I don't know how to get it out, but I'm going to worry about that later, because for now what we need to do is measure the stroke, thank you, of how much this goes in and out when we step on the pedal. But at the moment it's out all the way, so I'm going to, if I can figure out how to take that off, oh there we go, I'm going to undo this little nipple and let the oil come out so I can push the cylinder back in, and then we'll do it up, and then I'll step on the pedal and we'll measure how far it comes out. Oh, are you okay, buddy? What's this vigour?
Is anything coming out?
Yes.
Oh.
Lots of very watery oil. It's also very dirty.
Do you want to try and put the stick in?
Yeah.
Oh! You got to point it down. Oh! Oh, it's like an udder.
It's very sprung. Okay. So it might just spring out now. Yeah.
It wants to spring out.
It wants to spring out. So we need to kind of measure this now.
Okay.
I'll hold it in place.
I'll get a measurer.
Okay.
I'm scared of it.
No, don't be scared. It's very... It's not heavy, but you know what I mean. Okay, so that's at like 45 mil at the moment.
40. Is it going to fire out?
Oh, ready?
Yeah. Oh. Oh!
Oh, moose. Can that go on YouTube? There you go.
Okay, so that's basically all the way out, is it, stroke? It's like 60 now. So, shall we take another measurement if you step on the clutch?
Yeah.
See? I've never stepped on the clutch.
I've never stepped on Moose's clutch. That was very,
erotic.
yeah, it was, wasn't it? Moose, you gotta chill out. Okay.
Ready?
Yeah. Oh, yeah, it only came out like 10 mil. So we know that this isn't like broken, and the actuation from the pedal and stuff works.
Yeah, the pedal seemed normal.
You were saying that the pedal went right the way down.
Yeah, and it was really light.
It was really light. So that's what it should be like when we have the air assist. The pedal is just opening an aperture within an air valve. So that'll be really nice and comfortable to use.
Okay.
And then whenever you change gear, it'll go psh.
Yeah. Okay, let's do it. Sounds fun.
Let's see if we can get this bolt out. So my idea is I've got this bolt. I've like cut a kind of a tab in it and weld that onto the little nub that's poking out of the snapped bolt. And then hopefully we just get a socket on it and take it out. Not very hopeful. So the good thing is the gearbox is aluminium, so I won't like weld the bolt in, and the heat might actually help it. So let's just see, shall we? Let's see what happens. Cool, this is well fiddly. I think that's as much weld as I can get on that. Okay, I've got a ratchet on it. Oh, this isn't going to work. I can already just feel it bending. The weld. Oh! No, yeah, it just snapped right off. I wonder why it's such a good weld. Okay, I just did it again. Re-welded it on. Oh, it definitely feels like it's not just bending the welds. No way. I'm not sure.
It's very tight.
Oh no. It moved a little bit, but I just can't get a good weld on it. Okay. What do we do now?
I don't know.
We're going to put it back in and test it, aren't we? We could try just putting one bolt in.
Yeah.
A new one, not a crusty old one.
Yeah.
We've just reattached the cylinder with one good bolt, and now we're going to go and step on the clutch and see if it's lighter than it was when we first got the truck. Okay. Oh, it's always fun to sit in Moose. God, yeah, that's heavy.
Still heavy.
I mean, it's doable.
Can you get your foot to the floor?
Yeah, I'm actuating the full clutch. But there's...
Oh, truck's moving.
You have a go.
No, I don't.
Yeah, have a
need
go.
to have a go.
So you can see what it's like. Just to make sure it's not me just being a wimp.
Oh, jeez. I can't push that down.
Yeah, okay, it's not just me. You're like standing on it. You can do
insane.
it. Yeah, it is. You feel like it's not quite right. But give it one last go. See if you can get it down.
Oh.
Okay, good. Okay. It's not just me. Okay, so air assist clutch.
Yeah, I
install.
agree.
Okay. Look at your nice welding table being used.
Why is it mine?
Well, I don't want one. Cool, we've used the welding table mostly to use the mag drill to make these plates for the legs. I might have forgotten to get these cut with the rest of the laser stuff, but we made a few of our own and they worked out quite well. So this will be the plate that bolts onto the underside of the table, and now we got to weld these in place and hopefully line them up. So now, right, with that one, we can clamp it. So that'll stay there and hold that on, and this will go on here.
Clamp it.
On. Okay.
Yeah.
I hope they line up.
Hefty.
These are the legs for the table. They're way overkill, but I really like it. So this face here, this is what's going to bolt to the underside of the table. And then this is the feet essentially. So the legs would usually just be box section that comes down with a plate and then a caster on the bottom. But these casters are actually too big in one dimension to fit on the bottom of the leg. This chunky U section, this is the foot essentially. And then these just happen to fit really nicely on the ends that way. So there'll be one there, one there. Cool. And we got our clamps all made up. We had clamps making clamps earlier. It's great. So yeah, we'll see how this goes. See if it moves a lot. Hopefully it won't move. Very pleased with those. Just going to plug weld these on because
what's the point in
it's getting late.
them on?
Like we could drill and thread the holes and stuff, but we're just going to get them on there. That did not weld nicely. I'm not sure what metal this is, but it's something very cheap. Doesn't weld particularly nice. That's not coming off.
Now do.
I was having fun.
Okay. Should we try and get it under there?
Yeah.
Oh my god.
Okay. Okay.
Looking for...
Oh yeah, these holes line up.
Of course they do.
Of course they do.
We tried so hard.
Yeah. Oh yeah. That's very satisfying. Yeah. I just hit it with a wire wheel brush and then oiled it just to protect the steel, stop it from going rusty. So yeah, it's done. Legs are on, they look great. And it's really strong. And I like how it all fit together really well. The plan, really good. I definitely recommend that. It only cost like 20 odd quid. So now we're ready to get welding the aluminium storage boxes for the truck.
Finally.
Finally. Yeah. We got some testing to do. Oh, you okay? We're going to gather some data. Nothing too scientific, just some
it's
things.
very scientific. We're going to test impact resistance, flex, adhesion, and strength. First, we have to take off this pill ply.
Oh, that's quite satisfying, isn't it? The surface looks very nice.
It's perfect.
So the way we did it was each one had the two different surface options.
Yeah, and then we like switch them round so that we'd be able to compare the inside corners to the outside corners as well. Just first impressions, the epoxy, the finish on it, just looking at it looks a lot better than the vinyl ester. It looks like it was a lot more difficult to wet out the fiberglass with the vinyl ester, maybe because it was so thin. Like, looking at it, you can see like dry patches through it. The epoxy did a lot better. And looking at the difference between the twill and the plain, the finish on the twill is 100%
Much
better
nicer.
on all of them. Even though it's more expensive, you can see why it's more
Yeah, it's twice
expensive.
the price.
But it just looks so much better, and it's just done a much better job.
So the other question is how tight and how neat and sharp are the radiuses on the ones where we use 600 gram mat compared to 440? No, it's going to be quite minimal, isn't it?
Yeah,
Or do they feel the same?
they feel the same.
Yeah.
There's really not much in it.
Okay, well that's good to know.
The ones with the 600 mat is significantly stronger. Like way stronger. So even though it's just a little bit more, it still feels a lot stronger. And it wasn't that bad working with it.
Okay, shall we start
You want to start heating
testing it? Yes, I do. Okay, this is our adhesion test. We're just going to test which resin sticks better to the polyurethane foam. So there's two layers of 440 with the twill on the top. And you can kind of see, even though I used the same amount of resin, and they both looked really well wetted out, this one still got dry bits. I think it's a little bit of an illusion with the vinyl ester. It looks wetted out, but you actually need to put a bit more on. But with the epoxy, when it looked wetted out, it was. This didn't have the peel ply on top. We wanted to see what it looked like, so you can kind of see the differences.
I think the peel ply is necessary.
Yeah. Okay, let's try and pull this off. I have a feeling that the foam is going to be the weakest link. Oh! Yeah. I just tore a layer of foam off. So the layers didn't break. I wonder if I can pull the two layers apart.
Oh! You pulled it apart.
Yeah, I'm just drawing the weave. Interesting. Okay. Yeah, again.
That was much deeper. You took a lot more foam off that one.
Yeah. Epoxy is known for being a better glue than polyester-based stuff. But it's still, I can still pull the layers apart.
Do you think we didn't do a good enough job?
Yeah, this might all just be void because we didn't do it properly. Okay. Moving on.
Let me mark down the winner.
Do you think there was a winner?
Yeah, I think epoxy was stronger. This is not being used. Winner.
Win.
Loser.
Loser. I'm not quite sure if we can test how flexible it is. It's not really flexing, it's just wanting to break off of the polyurethane. So that's the epoxy. Oh, it's not as bendy. Oh, it just kind of cracks. And again, it's just breaking off the polyurethane foam. And then this is the 600.
Yeah.
So I'm testing these edges which have soaked up a bunch of resin, and like you can tell the 600, it flexes a bit but then it comes back, whereas the 440 stuff kind of cracks.
Okay, so do we want it to flex?
I don't really know.
How do we tell what's a winner?
I don't know. I just know that the vinyl ester 440 gram layering is the most kind of soft to flex.
I don't know if it's thick enough to have
not
it
sure.
on the walls of the habitat.
Least flexible is the winner. Let's just say that.
Okay.
Epoxy 600 is the winner, followed by the vinyl ester, and then this is third, and that's fourth.
Okay.
Science. So this impact bit, I kind of want to see how good it's going to be, like if we're driving down the road and a tree branch is there and it smacks the side of the habitat. That's what I'm worried about the most.
Yeah.
Because if that happened and the box was made of aluminium, then you could end up with a dent. Dented aluminium, it's going to be really hard to fix. But this, we want to kind of see, like, does it crack? Or does it, like, crush the foam underneath? Does it, like, chip off? Like, what happens?
But also we want to see, like, which can withstand the most. That's why you should use a hammer.
Yeah. It's trying to mimic a tree branch, and this is the closest thing I could find. But I don't think it's even going to...
He looks good.
Yeah. So let's just say tree branches aren't going to cause that much of an issue. But, I mean, I wasn't swinging that tree branch at like 50 miles an hour. Okay, here we go. All right.
You should probably start at number 1. 440 times 2 with epoxy.
Okay. That was loud. I didn't even make a dent.
No, it didn't.
Do you want ear defenders?
Yeah.
Yeah. I'll try again. I'll hit it a bit harder. It's not even denting it.
What?
Or should I try it with the big hammer?
Okay. Whoa.
Nothing. We'll show you a close-up in a minute.
Well, a close-up of what?
What's this? This is the 600 gram with a 400 gram.
Yeah, I'll get a close-up this time.
The biggest hammer you got. Swing it back and launch it like it's hot. It's a hammer. Hit it with a hammer. Hit it with a hammer. If something needs
I can't even see a mark on it.
It just looks dirty from the hammer.
Yeah. Like, that's why I hit it with this one twice.
Yeah, and that didn't even, like, there's no question it didn't even delaminate on that one.
No.
Still looks exactly the same.
So at the end, we're going to have to see how hard you have to hit it to actually get it to break. So, like, I think we're going to be okay unless a tree falls on the truck. Okay, vinyl ester. So this is part of the polyester family. It's not as strong as epoxy, apparently. It's more brittle, but vinyl ester kind of is somewhere in the middle between polyester, which is more brittle, and epoxy. So that's why we went for the vinyl ester. It's also 4 times cheaper than the epoxy resin, which over a massive project like this is significant money. So hopefully this doesn't crack. Any different? I'll hit it in the middle to avoid any delamination around the outside. Oh, I caused some because I hit it kind of close to the edge. So what's happening is if I hit it kind of close to the edge, it forces these two bits kind of apart and causes some delamination. Try and be a bit more accurate. Let's try the big one. This top layer is the plane weave, the thicker plane weave, and you can really see how it's not conformed as well into the gaps. So this is the 600 gram with a 400 on top, and then the twill on top of that. So this should be even stronger than that. Oh, that's rock hard. Yeah, it's just doing what the other ones did. It's just pulling away at these edges, these bends.
Well, impact-wise though, it's not doing anything
Absolutely nothing.
on any of them.
No.
So they all win.
Yeah.
The real question is, can we get away with using polyester or vinyl ester
Yes.
over epoxy?
Okay. So impact, I think we'll just call it a draw.
Yeah, they all win.
Good job, everyone.
Yeah.
Okay.
I look forward to making a graph out of this later. How would you plot this?
I'm not sure. Okay, so maybe the last test, we're going to put them this way up and then stand on them, and then that's going to force these two edges to go split and splay apart, and that's going to test the lamination strength. Okay, number one, I'll lower my weight on. I'm on it. It still looks fine. Was it flexing?
No, the floor was flexing more than that. You did it.
Okay. But again,
This is the heavier
Heavier
fibreglass, the 600.
epoxy. Oh! It's just the where it glues to the foam is breaking.
Yeah.
Okay, I won't break it anymore because I want to hit it with the hammer just to see how much it takes. Okay, vinyl ester. Oh, it feels harder. I mean, my scientific test is not. Oh, there you go. Where did it break?
Same
exactly
place.
the same place.
That seemed like it held on a lot longer though.
I think it did, yeah. Vinyl ester, 600 gram with a 400 gram. Oh, it feels even stronger.
It's just the foam giving out.
Yeah.
It's
It is.
leverage. And before you completely destroy them, now I think we've got a decent flap on all of them, so we can maybe see how strong that is. That's not going to do anything.
Is that even stronger?
Cool. Yeah, it is. It's substantially stronger, even though it's only a couple of 100 grams.
So this is the vinyl ester now. I hear more cracking.
Yeah. It's just a lot easier to
Bend.
maneuver. Yeah. But I don't know if that's good or bad.
It's like, at what point does it become brittle and deform? So it's like elasticity.
I would say, I don't know. I really don't know.
Could I have a go?
Yeah.
Just try and break that one. I mean, it's still not really cracking. If I go the other way. Like it still just is springing back. It's kind of fractured apart into lots of little spikes.
Try and bend the epoxy on.
Oh, it is significantly harder.
Yeah, it's so strong.
I can't. It just springs back.
What have we learnt?
I don't know. I'm going to hit it very hard with the hammer, and then we'll come up with some sort of conclusion, shall we?
Okay.
It's just slightly delaminating it.
But like even the foam isn't getting a dent.
No. Chuck me the actual foam. There you go. This doesn't have any fiberglass on it. Yeah. Yeah. That's what I was expecting to happen to the fiberglass. I would just break through it and they'd leave a big old dent. But it doesn't. It just absorbs it and just cracks, like a little bit. The surface is like a little bit rough. So the resin's fine. The weakest point, again, is the foam.
Okay.
That foam smells like fish. So here are our highly scientific results. I don't think we've figured anything out that hasn't already been figured out on the internet. That epoxy is stronger. Polyester and vinyl ester is more than likely to be more than strong enough for what you're doing. Yeah, I think the weakest point is always going to be the foam.
Yeah.
Why would you go for epoxy resin over the vinyl ester?
I think if we can try again with the vinyl ester and make it look as nice as the epoxy and get it really nice and soaked, then there's no reason to use epoxy over it.
No. But the other thing is, the vinyl ester is much easier to work with over a longer project. So if you are doing something that takes a couple of days and you lay up a section and use epoxy, when you come back to it the next day, you'll have to take the peel off, sand a decent portion of it, get it really clean before you can start laying up on it. But if we used vinyl ester and we come back the next day, you can pretty much just carry on. There's no extra steps, from what I've kind of learned from research. So just a very quick recap, if you're kind of new around here, the original plan for the habitat was to frame it out of aluminium. And these chamfered edges, these would have been aluminium folded, and then we would have adhered composite insulated panels to the frame. But the more we dealt with getting aluminium cut and bent, the more we realised how long it all takes, and it just causes delays. This way, it might take us longer to make the habitat, but at least you guys can watch us do something.
Yeah.
So I do actually think that using the fiberglass for everything is going to be better for weatherproofing and I think maintenance in terms of like dealing with impacts and scratches and stuff. And also while we're fabricating aluminium, if we're welding, we blow through all the seams and stuff. It all has to be so well done to stop water from getting in.
This isn't going to let any water in.
No, we're going to have a really well sealed habitat.
Rot free.
Rot free, we're not going to be using any wood. It's all going to be composite plastics. And, you know, if there's ever a massive flood, we'll just bob around in our habitat. Also, we are going to need a different set of tools to do it this way.
What are we going to need now?
We're going to need that table saw you've always wanted. Yeah, a table saw to cut the foam, to get the angles and stuff, will make our lives much easier. And some really good PPE. Because that's the other thing with this, it is quite stinky. And there's going to be...
Especially the vinyl ester.
One last thing then to talk about is this stuff. This is GRP box section. GRP just stands for glass reinforced plastic or glass reinforced polymer. For the framing, as you saw in the drawings earlier, we're thinking of using this and encapsulate it inside the foam in between the fiberglass. So we could use this sort of stuff to frame out around our slide outs, around doors, floors, areas where we need just a bit more rigidity, or anywhere where we want to mount stuff to the walls, like cupboards and stuff like that. We can embed and hide this in the walls before we put the inner layer of fiberglass.
And you can just scuff it back and it will adhere to it really well.
So that's one idea. I'll have to double check prices and stuff because it might be that this is actually more expensive than aluminium for the same amount of strength, but it's very cool.
Yeah.
So that's our ideas. We would love to hear your thoughts. Anyone that is boat builders, fiberglass experts.
GRP enthusiasts.
Yeah.
Send advice.
Yeah, let us know, please. I think that concludes our fiberglass science session.
And it concludes our episode.
Thank you so much for watching.
Bye.
See ya.